Hey, this is Horner, and this is electricity worksheet number 4, and this is the solution to number 3 on that. Sometimes on the AP test, what they'll have you do is instead of seeing a circuit and being able to analyze what's going on, they will have you draw the circuit first to make sure that you know how to draw a circuit. And then they will also have you go through and do some analysis. So they've got you doing a little bit of both. The first thing we want to do is sketch the diagram of the circuit to the right. So we're going to draw the circuit over in this area. We have a 10 ohm and a 15 ohm resistor. So we know that a resistor is a line that has a bump in it like that. And it's connected in parallel, so we know what that looks like, and it's placed across the terminals of a 15 volt battery. So let's go ahead and just draw our battery first. So there's our battery. We always want to have one line longer than the other. That's one thing we look for. You can also draw like this, because sometimes just one line with a short line is what we call a cell, and if you put more than one cell together, you make a battery. So that's probably a little bit better for a battery. We want to label it as 15 volts, and then what we're going to do is we're going to draw a line out. We're going to come down, come over, we're going to draw one of the resistors. Doesn't matter what it looks like, it's just as long as you get it in there. We want to make sure everything is connected there. And then we'll do the other resistor. And you really want to leave a little bit of room so that the reader can see exactly how you have it set up. This resistor we know is a 10 ohm resistor. And then above this resistor, we're going to put a 15 ohm. Best thing to do is put them on top. So, and then below the battery, I usually put the voltage, but then on everything else, I try to put them on top. That's just kind of something that I end up doing. So totally up to you if you want to do it that way or not. I'm going to switch to blue. Now they want us to calculate the equivalent resistance of the circuit. So remember, equivalent resistance is just the fancy name for the total resistance of the circuit. I'm going to make my pen a little bit smaller here, make it a little bit easier to write and to read. And I'm going to say that 1 over the resistance in parallel is equal to 1 over the first plus 1 over the second resistor. That's equal to 1 over 10 plus 1 over 15. When I get my answer for that, it's going to be 5 over 30. But I don't want 5 over 30. I'm going to need to flip that. So remember, I'm solving for RP. So if I want to solve for RP, that's going to be common denominator here is 30, or you could do it in your calculator. But whatever you do, you got to flip whatever you're doing. So that's going to be 30 over 5. So the total resistance in parallel is equal to 6 ohms. And that's all they really wanted. For letter C, it says calculate the current through the entire circuit. So if I want the current in the entire circuit, on the AP equation sheet, it says the current is equal to the voltage over the resistance. This is going to be the total resistance in parallel, and this is the total voltage. And so that will be 15 volts divided by 6 ohms, and that will give us 2.5 amps of current. The last thing that we're going to do in this one is calculate the current in each branch. So I want to know what is the current here and what is the current here. So far we found out that if we put an ammeter right here, we'll get a current, so there's our ammeter, of 2.5 amps. We also know that if we put a voltmeter on each one of the resistors, that voltage is going to be the full voltage, which is 15 volts. So that's 15 volts for this one. And then for this one, if we do a voltmeter, so we can draw the voltmeter, and we put it right here, we're going to find out that this one is also 15 volts. For current, remember, in the 10 ohm resistor is going to be equal to the voltage divided by the resistance in the 10 ohm resistor. So that is 15 divided by 10, and that will give us 1.5 amps. And then finally in the bottom one, this is the current, so this was 10. A little hard to see. This one's 15, so this is equal to V over R15. And so this one is equal to 15 volts divided by 15 ohms, and that is equal to 1 amp. And now we know the current in each branch. How do we know that the current is this? Why is the current that way? Remember, current is always the loop rule. And if I wanted to know why is the voltage the same, we could say loop rule. Current is not the loop rule. Back up. Current is the junction rule. So junction rule is the current. Junction rule for current. And we said that the current going in has to equal the current going out. So when I come in, this is 2.5 amps. When I hit the junction, then across this 10 ohm resistor, I get 1.5 amps. And across the resistor on the bottom, I get 1.0 amps. Then when I get to this junction, I have to add them back together again so that on this side, it's also 2.5 amps. The loop rule, remember, loop rule tells us why in parallel the voltage is the same. So that is our two rules again. So junction rule for current. So we said that current in, CICO, current in equals current out. And then the loop rule, the voltage is the same in parallel, and the voltage is the same really in a loop. And that is the end of number 3.